Greetings, my young math Padawans. Today we will be talking about transformations of absolute value functions. Before we get started, let's take a look at what an absolute value function graph actually looks like. It creates this V shape. And if you remember from class, I was talking the other day about picking numbers for our table of values. And in this case, you'll see that I went from -4 to +4 on the integers. And that's simply so I gave myself a couple more problems to come up with, or a couple more numbers to do. F of x is going to be equal to the absolute value of x. So each one of these coordinate pairs, in order to come up with the y value, I took the absolute value of the x value. So in this problem right here, for like 2, for example, I took the absolute value of the x value of 2, and because I know absolute value is the distance a number is from 0, in other words, it makes anything negative positive, the absolute value of 2 is +2. If I look here, for example, say at -3, the x value of -3, I would be taking the absolute value of -3. And since -3 is in fact 3 units from 0, the absolute value of -3 is +3. I'm hoping you remember this and have seen this before. But I went ahead and filled in the rest of this table using the exact same thought process. But how boring would it be if all of our absolute value graphs looked exactly like this? Let's think about it differently. Like, what about these two V's? They look the same, but you should notice a fundamental difference between them. You should notice that the graph on the left and the graph on the right look similar, right? They have a V that's opened up about the same amount. However, what you should notice is this point is in a different place on that other graph. And furthermore, if you look closer at it, you should notice that if I took the graph that was on the left of this screen, moved it to the right 3 units, and then moved it down 2 units, you would end up with the graph that's on the right. These are called transformations. And if you remember in geometry, you talked about transformations of shapes. You thought about horizontally and vertically shifting a shape. You called those translations in geometry. You talked about shapes being reflected. And we still call those reflections in algebra. You talked about these shapes being zoomed in and zoomed out. Remember that one project you did in geometry? This you called a dilation. But in algebra, we got to talk about this just a little bit different. We call those shrinking and stretching. Today, we're just going to focus on the first one, horizontal and vertical shifting. So we won't get into anything too complicated today. What does it mean for a graph to move vertically? I really feel like we got to get into some of the notation here, which you did not talk about in geometry, but we're going to absolutely hit on it in here. When I move a graph up and down, it has a general form that looks like this, y equals f of x plus k. The value for k is going to talk about where the graph is moving up and down. So for our graphs, it's going to look like y equals the absolute value of x and then plus some number. That number is going to represent how much our graph is moving up or down. And down, why do I say down? I say down because if that value, if this number for k, the value for k, is less than 0, my graph is going to move down. And when the value for k is greater than 0, my graph is going to move up. Let me show you what I mean. Let's consider the function g of x equals the absolute value of x plus 3. Hey, remember that g of x, that's just a fancy way of writing y. So we're going to look at the graph of the absolute value of x plus 3. Well, before we do that, we need to realize that this is exactly the same thing as the graph of the absolute value of x. But according to what I just saw on the other slide, I'm going to move this up 3 units. So I'm going to move up 3 units. Before we do that, I'm going to put the graph of the absolute value of x on this coordinate plane. I'll do this with dashed lines just so we don't get that confused with what g of x is actually going to look like. Now, the absolute value of x has that table of values. We can go back 2 slides. We can look at what that is, right? It's 1, 1, it's 2, 2, it's 3, 3, it's -1, +1, -2, +2. It's those coordinate pairs. But in order to graph the absolute value of x plus 3, all we're going to do is we're going to take this entire graph and we're going to move it up 3 units. So my new vertex is right there. I'm going to take a next point, pick any point, and I'm going to move it up 3 units and plot it in its new location. Same thing over here. I can move it up 3 units and plot it in its new location. Let me fill in a couple other points to make this a little bit easier to graph. And now I can just take my ruler and I can draw in the graph of g of x. I'm going to label it so we don't get it confused. This is the graph of the absolute value of x plus 3. And as I said, you can see that it's different from the parent function, absolute value of x, because it moved up 3 units. But remember, I said functions can also move down. Like in this graph, g of x is equal to the absolute value of x minus 5. This minus 5, right? This minus 5. This minus 5 is going to move my graph down 5 units. So again, we'll take that parent function, and we'll take each point and move it down 5 units. So again, this vertex moves it down 5 units and puts it here. Maybe a point over here, we put it down 5 units, and it's now here. Maybe this coordinate pair over here at x equals -1, we'll move it down 5 units and put it here. Right? We're moving it down 5 units. Let me fill in the rest of these points. Okay? And then I can draw my line. And we get the graph of the absolute value of x minus 5. But graphs don't just have to move up and down. They can also move left and right. This is what the rule for the transformations of a function that looks like it's moving to the left or to the right. We call it shifting it horizontally. It will be y equals f of x minus h in the parentheses. Notice those parentheses. That's going to be really important. For us, with absolute value graphs, it's going to look like this. It's going to look like something equals the absolute value of x, and then we're going to say minus a number, or plus a number for that matter. But that value for h is what's going to determine whether we move to the left or to the right. And again, when the value for h is negative, we're going to move it to the left. And when the value for h is positive, we're going to move it to the right. Now, I want to keep something in mind here because this is going to be a little bit tricky when we move forward. Let me talk to you about that. Look at this problem right here. G of x equals the absolute value of x plus 3. We have to be careful. If you go back and you look at the previous page, you saw that the rule was f of x minus h. And I told you that for us, that's going to mean the absolute value of x minus some number. That value for h is going to be really important here because if I look at this, I have an addition sign. There's an addition sign right here, not a subtraction sign. So I want you to be really careful about this. That means that if I want to change this, I need to really think about g of x as being written as the absolute value of x minus, and remember, double negatives give me the addition, minus -3. And in this problem, that means my value for h is equal to -3, which translates to me moving it to the left 3 units. Not to the right, like we might think it is because it's an addition sign. Folks, it doesn't matter to me whether you want to write it out like this, change it to the subtraction, or if you just want to remember when you see an addition sign inside absolute value, it means we're moving everything to the left, that number of units. And in this problem, that's exactly what we're doing. Let me put that parent function on this graph for us. Now, just like when we were moving functions up and down, in this case, we're going to move everything to the left 3 units. So that means that the vertex point that's right here, we're going to move him to the left 3 units to create a new point. We'll take this point that's up here, right? We'll move him to the left 3 units. Careful, that the one that's over here at -1, +1, we're going to move him to the left 3 units as well. Go up here, pick a point, move it to the left 3 units. Move this point here to the left 3 units, and we'll be able to create our graph that has been shifted to the left 3 units. Let's take a look at another one. This function, g of x equals the absolute value of x minus 5. So remember that when we had the previous problem, x plus 3 inside the absolute value, it moved it to the left 3 units. This is a minus. What do you think is going to happen? You got it. In this problem, we're going to move it to the right 5 units. So that's going to be the difference here. And again, do we have to go through all of that? I don't know. In this problem, remember, it's in the absolute value of x minus a number. That's exactly what we want it to be. We can see that value for h is equal to 5. That is a positive 5, which is why I'm moving it to the right. If you have to think about it that way, do it. But remember, when you see the subtraction inside, instead of making me thinking negative direction, think that that minus on the inside means to the right. It might be just easier to think of it that way. We're going to graph this exactly the same way. We'll put that parent function on this graph, and then we'll shift each point to the right 5 units. So my vertex is here. Yep, looks like I'm going to go off the graph a little bit. It'll be okay. We can make sure that we get those other points to the best of our ability. And then we can connect the points with a line. And we're good to go. That brings us to our first example problems. So why don't you take a minute right now, pause the video, and I'd like you to try these 2 different problems. Think about how we can move functions to the right, to the left, up and down, and see if you can come up with the answers in the correct graphs for these 2 problems. That's right. Pause the video right now. I'll be here when you get back. Okay, now that you've had a chance to work on these problems, let's go over them. In part A, that x, the absolute value of x minus 2, you should know that this means I move everything to the right 2 units, which means your graph should look like this. For B, you should have said that this is moving up 1 unit, which means your graph should look like this. Okay. But we're not limited to just doing one transformation at a time. Take a look at this problem. G of x is equal to the absolute value of x plus 2 minus 3. That dramatic pause was very intentional. So if we look at this, we should actually see that there are 2 transformations to this graph. One dealing with the plus 2 on the inside, and one with the minus 3 on the outside. So we have 2 different numbers. We're going to have 2 different transformations. That means if we put it all together, this graph, the new graph, g of x, will be moved to the left 2 units and down 3. So again, if we take a look at our parent function, we're going to move each point to the left 2 and down 3. I like to always start at the vertex. So I'll take that vertex point and I'll move it to the left 2 and I'll move it down 3. So my vertex will now be right here. I can do this the same for any individual point. Go ahead, take your pick to do any point, trace it to the left 2, down 3, and you'll end up with a graph that will look like this, which looks exactly like the absolute value graph. Again, the shape didn't change. We just shifted it left 2 and down 3. Another 2 problems for you to try. Try these out. Again, look at the transformations. How are they different? What changed? What's the graph look like? Take a minute right now and do these 2 problems. Pause the video. I'll be here when you get back and we'll go over the answers. No, really? Pause the video. All right, for C, did you say that moved left 2 and down 3? If you did, you're right, and the graph would look like this. What about for D? Did you say right 1 and up 2? That's correct, which means your graph should look like this. Good job, folks. So that's all I have for this lesson, talking about just shifting our graph to the left and to the right. Of course, there are more ways that these absolute value graphs move, but that's for a different lesson. Now it's time to get some practice done. Please, as always, let me know if you have any questions. Thank you for listening.